everyone. In previous lecture we have discussed about electric current, flow of electric charge, drift velocity and mobility. In today's lecture we are going to discuss about Ohm's law, electric resistance, VI characteristic, Kirchhoff's law and its application, electric power and energy. First we are going to see about Ohm's law. According to Ohm's law, at constant temperature, the current flowing through a circuit is directly proportional to potential difference between two ends of a conductor. V is directly proportional to I. V is equal to constant into I. V is equal to IR, where V is equal to voltage across the conductor, I is equal to current flowing through a conductor, R is equal to resistor. I is equal to V by R is equal to V by I. The SI unit of resistor is ohm. Next we are going to discuss about application of Ohm's law to determine voltage, resistor or current in any electrical circuit. Ohm's law is used to maintain a desired voltage drop across electronic component. Ohm's law is used in DC meter and other DC shunt to divert a current. Next we are going to discuss about limitation of Ohm's law. Ohm's law is not applicable for unilateral element. Such type of network consists of transistor, diode, etc. Ohm's law is not applicable for non-linear device. The non-linear element which do not have a current directly proportional to the applied voltage. This means the resistor value changes for different values of current and voltage. Next we are going to discuss about electric resistance. Resistance is a measure of opposition to a current flow in an electric circuit. The opposition offered by an ion is called as resistance of conductor. This resistance is also known as ohmic resistor or electric resistor. The SI unit of resistor is ohm or volt per ampere. The resistance of a conductor depends on the following factor. First one, length. Second one, area of cross section. Third one, material of conductor. Fourth one, temperature. The resistor of conductance is given by a formula R is equal to rho L by A, where rho is equal to specific resistor or resistivity. It is expressed in ohm meter. Next we are going to discuss about VI characteristic. If voltage and current are in positive in nature, then VI characteristic curve will be positive in first quadrant. If voltage and current are in negative in nature, then VI characteristics are in negative in third quadrant. For purely resistive element, the relationship between voltage and current are linear and constant at constant temperature. Next we are going to discuss about ohmic conductor. Those conductor which obey Ohm's law are called as ohmic conductor. Example, all metallic conductors are ohmic conductor. VI characteristic graph for ohmic conductor is straight line. Non-ohmic conductor. Those conductor which does not obey Ohm's law are called as non-ohmic conductor. Example, diode valve, triode valve, transistor, vacuum cleaner, etc. The VI characteristic graph for non-ohmic conductor is not a straight line. Next we are going to discuss about Kirchhoff's law. There are two laws given by Kirchhoff for determining the potential difference and current. First, Kirchhoff's current law. This law is also known as junction rule or Kirchhoff's current law. According to this Kirchhoff's law, the algebraic sum of current entering a junction must be equal to 0. Summation I is equal to 0. In an electrical circuit, at any junction, sum of current entering a junction must be equal to sum of current leaving a junction. Let us consider a diagram with a 4 current I1, I2, I3 and I4 meeting at a node point N. The equation can be written as I1 plus I3 is equal to I2 plus I4. I1 plus I3 minus I2 minus I4 is equal to 0. Kirchhoff current law is based on law of conservation of charge. For example, in any electrical circuit, the current flowing towards a node must be positive. The current flowing away from the node must be negative sign. Next we are going to discuss about Kirchhoff's second rule. This law is also called as loop rule or Kirchhoff's voltage law. According to this law, the algebraic sum of potential difference in any closed circuit is equal to 0. Let us consider a diagram with voltage source and 3 resistors R1, R2 and R3. The equation can be written as summation V is equal to 0, summation E is equal to summation IR. Sum of potential drop is equal to sum of potential rise. From the above equation, IR1 plus IR2 plus IR3 is equal to V. Kirchhoff voltage law is related to law of conservation of energy. Next, we are going to discuss about application of Kirchhoff's law to determine the value of current flow and voltage drop in different part of complex circuit. It helps in knowing the direction of current in different loop of electric circuit. Kirchhoff's law are useful in understanding transfer of energy through an electric network. Kirchhoff's law is applicable for both AC as well as DC electrical circuit. Next, we are going to discuss about electrical energy and power. The capacity of doing work is called energy. In an electric field, energy stored in a form of charged particle is called as electrical energy. Power can be defined as work done per unit time. Electric power is a rate of energy consumed in an electric circuit. The equation can be written as P is equal to W by T, where W is equal to work done, T is equal to time. In the another form of power, the power is defined as a product of voltage into current. The equation can be written as P is equal to V into I, where V is equal to voltage, I is equal to current. The SI unit of power is watt. We came to the end of a section. I hope that you all understand the topic about Ohm's law, electric resistance, VI characteristic, Kirchhoff's law and its application, electrical energy and power. In the upcoming section, we are going to discuss about carbon resistor, color coding of carbon resistor, series and parallel combination of resistor. Thank you.